Hello and welcome back to my YouTube channel. I am Shlok Kulkarni and today I am back with my quiz series. We are going to look at some random 8 questions from various topics of MET, REGS, NAV and Tech. So let's begin with today's question. Question number 1. Aircraft is deemed to be in flight when? From the time aircraft moves under its own power until it comes to rest after landing, from the time the main wheels lose contact with the runway until they again touch the runway after landing, from the time aircraft moves into maneuvering area until it comes to rest after landing, from the time the engines have started until they are shut down. So, by definition of according to ICAO, aircraft is said to be in flight when it moves under its own power until it comes to rest after landing. So option D will be wrong. Why? Just starting your engines and waiting on the ground. Okay, starting your engines with waiting on the ground is not the definition of flight time. So aircraft is deemed to be in flight, or flight time starts from the moment after you start your engine. You also begin to move your aircraft on the maneuvering area or taxiway. So that is your definition of aircraft flight time. Option B will be wrong because it states that flight time means the moment you lift off from the runway to the moment you touch down on the runway at landing. So that is again wrong. In your flight time, all that time is also included, which is spent in taxiing your aircraft and in doing a takeoff roll on the runway. Not just the lift off to touchdown, but also what happens prior to that. That is taxiing on the runway, taxiing on the taxiway, and if you are doing a takeoff, then doing a takeoff roll on the runway. So this procedure is also included in flight time. From the aircraft moves into maneuvering area until it comes to rest after landing. So this is an irrelevant option. So correct option will be from the time aircraft moves under its own power until it comes to rest. Now it so happens that you may have observed at large airport buildings, all aircraft are parked near the terminal, airport terminal, where passengers are transported from the terminal building to your aircraft, okay, to the aircraft via a bridge. There is a bridge, via bridge that passengers move from terminal building to that aircraft. Now, when all passengers have boarded and cargo loading has finished, servicing of aircraft has finished, this aircraft or this particular aeroplane is pushed back. Okay, there is a vehicle on the ground that pushes this aircraft back towards the taxiway. Okay, after pushback is completed, this aircraft starts its engine. Okay, so after starting its engine, it gets taxi clearance, and from that moment it starts taxiing its aircraft. Okay, so engines are not always started where aircraft are parked. If aircraft is parked near terminal building, after pushback procedure, it will start its engine. Question number 2. Heading magnetic is 215. Variation is 10° west. What is true heading? So this is magnetism chapter, very simple sum. That is your variation. What is variation? It tells you about the relationship between true heading or true direction and magnetic direction. True and magnetic direction, right? So if variation is west, magnetic will be best. If variation is east, magnetic will be least. Okay, this is the code that we have to remember. So variation west, magnetic best. That means with variation west, your magnetic direction will be more than your true direction. So you will add variation to your true direction to get magnetic direction. Variation east, magnetic least. That means to obtain magnetic direction, you will subtract variation from true direction. Now let's coming back to this question. We have magnetic heading of 215 and variation 10 west. So variation west, magnetic will be best. So that means to obtain your magnetic heading, you will add variation to true heading or true direction, right? According to this formula, variation west, magnetic west. So according to this, magnetic is equal to variation plus true. Now let's substitute the values. Magnetic direction is 215, variation is 10, and we have to find out true heading. So true stays as it is. Therefore, true heading or true direction will be equal to 215 minus 10. Therefore, true direction or true heading will be equal to 0, correction, will be equal to 205 degrees. So this is your answer. Your true direction will be equal to 205 degree. So this is a question that is often asked in DGCA exams. So make sure you score full marks in such simple questions. Okay. It saves time also. Not much time is required to solve this question. You can do it mentally also. So read that chapter and solve all similar questions from that chapter. Let's go to question number 3. The shortest Rhumb line track and distance from 50 degree north 175 west to 50 degree north 175 east is how much? So we have to find out first Rhumb line track, that is Rhumb line direction from point A to point B, and we have to also find Rhumb line distance. So let's find Rhumb line track first. Now whenever Rhumb lines are concerned, I have always repeated this in various quiz lectures as well as in various other lectures, that you have to draw the earth from the top. That means you are looking at the earth from the perspective of North Pole. With that you have 0 degree meridian, 180 degree anti-meridian. You have to the right hand side east hemisphere, so 90 degree east. You have 90 west, 180 east and west. Okay, so this is your complete basic starting diagram. Now let's plot point A. Now point A and point B, as you can see, both are at same latitude, 50 degree north, 50 degree north. Okay, so let's plot 50 degree north. Point A is in western hemisphere, so 175 west. Point B is 175 east in the eastern hemisphere, so just below 180 and more than 90, so 175 east. Also it is more correct to write 000 and 090, okay, because longitudes. Next point. Now we are going from A to B. The closest direction. So always we find the shortest distance. If we want to go from one place to another place, we find a way that will give us the shortest distance. So I can go from A to B clockwise direction, or I can go from A to B in anti-clockwise direction. So which way will this clockwise direction give us the shortest distance, or this anti-clockwise direction from A to B will give us shortest distance? So between these two, the clockwise direction from A to B will give us the shortest distance. So we will choose to fly a clockwise direction from Alpha to Bravo. So I'm going to erase these two arrows because we have made a decision to fly clockwise. Now all clockwise directions will be westerly directions. All clockwise directions are westerly directions. All anti-clockwise directions are opposite of that, which is easterly direction. Okay, so the answer to our question number 3, part 1, the Rhumb line track will be 270. Westerly means 270. So the possible option is A or B. If you don't want to do this Earth, there is another way you can plot this, which is like this. So 50° north, 175 west, 50° north, 175 east. Okay, since both are at same latitude, the Rhumb line will be a straight line, and it will be a all Rhumb lines run or go in east west direction. Go in east west direction. Okay, so of these four options, the only possible is east or west, and this way I have shown you. When you plot that on the Earth, it becomes easier to imagine than this one. Here you only get to know that straight easterly or westerly direction. Okay, there is your 180° meridian, right, between 175 west, and there is somewhere over here is 0° meridian. And this 175 east longitude I can also draw here. This 180 will be over here somewhere. So basically, this is your prime meridian. 175 west will be on its left hand side, 175 east will be on its right hand side. Now if I want to go from A, that is A to B. Okay, in the question we are flying from A to B. So I can either go following easterly direction, okay, or I can, the second option available to me is fly westerly direction and enter from here. So I will start from alpha, I will cross the anti-meridian, and I will come on the other side of the picture, or the other hemisphere, which is the east hemisphere. Starting from A, fly west, just cross 5 degree longitudes. There will be 5 longitudes between 175 and 180. Cross those 5, okay, and then cross 5 more and you reach 175 east. So 5 this and then 5 this. Only 10° of longitude change will take you to your destination. But if you choose to fly easterly, what will happen? We will have to first cover 175 longitudes and another 175 longitudes. So here only 20° of longitude change was there. Okay, 5 plus 5, sorry, 10° of longitude was there. If you choose to fly westerly, there will be 170 and 170. So approximately, so much more than 10° longitude change. That's why we choose to fly westerly, which is the shortest Rhumb line distance direction. Now let's calculate distance. What will be our distance? I will take a new slide. The distance, Rhumb line distance equals to d long in minutes into cos of latitude. So d long is how much? The difference in longitude between them is, as you can see clearly, 180 minus 175 is 5°. 180 minus 175 is 5°. So total will be 10°. So d long will be 10°. Let's convert this degree into corresponding minutes. So multiply by 60 into cos of latitude. What latitude they are situated at, both of them? 50. So cos 50. So 600 into cos of 50 will be how much? 0.64 something. So multiply that by 600, it will give you approximately 385 nautical miles. So your Rhumb line distance is 385 nautical mile. So closest option is option Bravo. So option Bravo will be the correct option. 270-degree true direction from A to B, and then a Rhumb line distance of 386 nautical mile. So this is how you plot this diagram and then solve the sum using formula. I always suggest students to draw this diagram for Rhumb line. It is easier to plot and check the directions. Question 4. During engine operation, if carburetor heat is used, what will happen? Now what is carburetor heat? So when you start flying in your Cessna, if you fly a Cessna, this is where the carburetor heat knob is situated, and you can use this or operate this by pulling out the knob like this. Correction, over here. Okay, just like this is pulled out, you can pull it out, the carburetor knob. Now carburetor heat is usually used when you descend from high altitudes to lower altitudes during descending. So when you use carburetor heat, what happens? The air that is coming from outside atmosphere in the carburetor area, okay, and then the engines, that air will be heated, okay, and this heated air will be mixed with fuel, and this fuel air mixture will enter the engine cylinder. Normally what we happen, we have normal atmospheric air entering the engine, which is at atmospheric temperature. When this mixes with the fuel, that normal fuel air mixture will go. But when we use carburetor heat, this carburetor heat will heat the air, and this heated or hot fuel air mixture will enter the cylinders. Now this is done to prevent carburetor icing. When we descend from higher levels to lower levels, and if temperatures in the surrounding region is in the range of plus 30 degrees Celsius, okay, positive 30 degrees Celsius, and relative humidity in the atmosphere is high, in order to prevent shock cooling during descending, we use carburetor heat. Now what happens to air when it is heated? When we heat air, what happens to its volume? Its volume increases. When its volume increases, its density, what happens? It decreases, because density equals to mass upon volume. So density is inversely proportional to volume, right? Inversely proportional to volume. So as a substance is heated, okay, it expands in volume. So if this is your air mass here, when it will be heated, what will happen to its density? Density will decrease, volume will increase. As a result, its volume will increase. It will become light. When density decreases, density of an object decreases, that object becomes lighter and lighter. So when an object becomes lighter and lighter, it starts rising in the atmosphere. It's part of meteorology. So volume or space is going to increase much more, okay, and it will become, that object will become light and light, thin or thin, okay. So in case of air becomes, as its density decreases, the air becomes thinner and thinner, and this less density air will not burn the fuel air mixture properly. A fuel air mixture in which density of air is very high or is high will burn more efficiently than the mixture of fuel air mixture with low density air or less density air. Okay, so when we have less density air in the cylinder along with the fuel, the engine will produce less power. Okay, so we always want high density air entering the engine, so that power that is produced by the engine is much more, and the fuel air mixture is burned properly. Because for ignition to happen, for burning to happen, okay, we have spark plugs which ignite the fuel air mixture. But in the absence of air, that is oxygen, okay, this fuel will not burn efficiently and a lot of fuel will get wasted. So this is the one side effect or one drawback of carburetor heat, that on one side it prevents ice accretion in the carburetor, but on the other side it also results in decrease in air density okay, because of which the engine power is reduced. So whenever you use carburetor heat, whenever you start flying, or if you have flown, you must be knowing this, that when we use carburetor heat, automatically the engine RPM, revolutions per minute, drop by 100 to 200 RPM, sometimes 100, sometimes 150 RPM. So you can see that there is a drop in the engine RPM or engine tachometer. Okay, this is due to less air density. So carburetor heat, the correct option will be delta, decrease air density to carburetor. It won't increase the fuel air mixture ratio because density has decreased. It will decrease carb temperature, no, it will increase carburetor temperature. Increase engine RPM, no, it will decrease RPM. Let's go to question 5. What is AGL? AGL is above ground level. Okay. In altimetry, we always come across MSL, MSL, that is mean sea level. AGL is above ground level. Okay. Vertical distances. Question 6. The inversion in the lower troposphere created by high pressure system during day or night is called what? Now whenever there is a high pressure system, so let's take, this is your land surface. Okay, this is your land surface. Now what happens during night time? During the night time, there is terrestrial radiation. During daytime, what do we have? We have insolation, that is sun rays are going to come from the sun to the earth. Okay, during night time when the sun sets, after sunset, we have terrestrial radiation, okay, more intensifying. Okay, in the absence of solar radiation, terrestrial radiation will dominate in the atmosphere. And due to this terrestrial radiation, our atmosphere is heated. Okay, our atmosphere gets heated up, right? Now when this terrestrial radiation is maximum, okay, whenever this terrestrial radiation on a particular day or night is happening at a great rate or very efficiently, the land will cool down, the land will cool down faster and will become very cool. Okay, so on a clear night, that is when there are no clouds in the sky, the winds are calm or the winds are light in wind speed. Okay, in these two conditions, when terrestrial radiation is happening very fast or very effectively, the land will cool down much faster. Okay, just like it becomes very hot during daytime, same thing when terrestrial radiation is happening very is happening smoothly, the land will get cooled down, the land will become cold, and as a result of that, the air layer, the layer of air which is close to the land, will also get this cold temperature and it will become cold due to process of conduction, due to the process of conduction. Okay, the transfer of cold temperature happens from ground or from the land to the air layer above it, but this is subject to only a few thousand feet of air which is in contact with the land. Okay, the other part of the air mass which is way above this air layer in contact with the ground, that is not heated or cooled down by conduction. Okay, so only that air layer which is in contact with the ground surface like this will be cooled down. As a result of this, what will happen? We will have very cold temperatures. We will have very cold temperatures near the ground level. Beyond this, when conduction process weakens, okay, there is no role of conduction, the air layer above this air layer will be at its normal temperature, which will be warm, which will be warmer. And from this layer, of air, normal lapse rate will resume, which is what, 2 degrees Celsius per 1000 feet. That means as you rise above this layer, the temperature of the air will go on decreasing, So it will become, again it will become colder and colder as you go higher up in the atmosphere. The normal lapse rate will resume. But what happens over here near the ground, there is cold temperature of air. So what we have, cold, warmer, colder. So this is not a normal case. The normal case states that as you go up in the atmosphere, your temperature should decrease. So beginning from ground layer where the temperature was cold, after this cold temperature, the temperature here should have been colder than that. But what we find over here, we have warm temperature. So that means this is called inversion. Okay, something inversion means the inverted or the upside down of some phenomenon. So normally we have normal lapse rate, fall in temperature, but the opposite of that is inversion, which means rise in temperature with increase in height. That is your inversion. Okay, so this is how due to intense terrestrial radiation after sunset, this inversion can take place. Okay, now what happens is that during daytime, next point that I want to explain to you is that during daytime, when we have the sun, we have this land surface. Due to the solar radiation of the sun, there will be a low pressure created on the land surface. There will be a low pressure created on the land surface because the land will get heated up. The land will get heated up. As a result, the air layer close to the land will also get heated up. Okay. So density of that air layer decreases. And when density decreases, the air mass rises in the sky. Air mass rises in the sky. And so as a result, this convective current will develop in the sky. And when this air mass goes up in the sky, in place of that air mass, okay, in place of that air mass, a low pressure is created. A low pressure is created. So this is what happens during daytime. Now during daytime, high pressure can also exist at some areas. There may be low pressure at some areas where heating of the land is very intensified. During night time, when the temperatures cool down, okay, during night time when the temperature cool down, and we at the same land surface when during daytime or afternoon time there was very strong low pressure. So right now during night time or after sunset, when the land has cooled down intensively, we will same thing, this low pressure will weaken. Okay, it will decrease in its value or quality. It will weaken, and if the land has cooled down excessively, it will diminish or it will disappear totally. And in its place, there will be high pressure created. There will be high pressure region created. Okay, so this is how inversion happens over here. This is how inversion happens over here. Cold, warmer than normal cold lapse rate. Okay. So in the inversion in the lower atmosphere is created by high pressure system. Why? So like I told you, due to nocturnal cooling of the land. Okay. The land surface cools down after sunset. So low pressure will die down. High pressure will be created on its surface. Due to high pressure, there will be stability in the atmosphere. The winds will be calm. Sky, if the skies are clear, one more good news. So the land will cool down much faster. The air in contact with the ground, like here I explained, it will cool down along with the land, and therefore it will become very cold because of conduction. But the air layer above that will be normal temperature, warmer than that. Okay, and this is how inversion is established. Okay, so that such a kind of inversion will be called radiation or terrestrial inversion? So the correct answer will be terrestrial inversion. Okay, terrestrial inversion. Let's go to question number 7. By definition, flight levels are surfaces with constant air pressure determined from a certain pressure value. Okay, constant pressure levels determined from a pressure value which is 1013.25 millibars. When you go above a transition altitude, okay, in the atmosphere we have transition altitude and transition level. So let's say when you are climbing, aircraft is climbing, okay, and when it is at or below transition altitude, as long as it is at or below transition altitude, all its vertical distances will be reported in terms of altitudes. The altimeter setting at or below transition altitude will be UNH. When airplane during its climb crosses transition altitude, it is the duty of the pilot to change its altimeter setting from QNH to standard pressure setting, which is altimeter setting which is 1013.25 millibars. Okay, 1013.25 millibars. And when that happens, the vertical distances will be reported in terms of flight level. Will be reported in terms of flight level. Okay, flight level 100 for 10,000, so on and so forth. Okay, so make sure that when aircraft crosses transition altitude, and it is the duty of the pilot to change its altimeter setting from QNH to 1013, okay, which is your standard pressure setting. So answer, flight levels are surfaces with constant pressure determined from 1013. Next question, question number 8. Before that, so you can see over here 1013.25 is the pressure level over here. From that pressure level, your flight level is measured. Okay, flight level is measured from 1013.25 pressure level, 1013.25 pressure level. Next question, a pressure difference of 10 millibars near ground is equal to a height difference of what? We know that 1 hectopascal of pressure difference is approximately 30 feet of vertical distance. So 10 millibar or 10 hectopascal will be equal to cross multiply 300 feet. So answer will be 300 feet. In case of meters, 1 hectopascal equals to 8 meters. So 10 hectopascal will be equal to how many meter? It will be equal to 80 meter. So we don't have option 80 meter here, we have 50 and 150. But we definitely have 300 feet given here, so correct option is 300 feet. So this concludes our lecture for today. I hope you have understood this lecture. You have liked this video, and if you have liked this video, do hit the like button. Subscribe to this channel so you keep getting new notifications on time, and do share this video with everyone. Thank you. All the best. Do well.